morning class or afternoon pala. So I just decided to record this lecture so that we won't miss any meeting for this course, because we've had a lot of Mondays with no classes. So if we include this one, then we'll be missing a few things. So for today, we're going to talk about the domain name system, on how to exploit the domain name system. For those of you who are taking ComSci 137, I think you already have had a laboratory exercise on the domain name system, and basically you set up your own DNS server. Now, DNS is an application layer protocol, and of course it sits on top of the TCP/IP because it is used by the internet. So let's start with the purpose of DNS. In this figure, you see here a user, and the user is invoking a file transfer client. For example, it can be a web browser or it can be an FTP client. For example, you have ftp.jackhermosilla.org. Now the client there is FTP, and the host name is jackhermosilla.org. Now jackhermosilla.org, that name will be sent to the DNS client. The DNS client is usually on the same machine as that of the application. Right? So you can see here in this diagram that the file transfer client is within the application layer as the DNS client. Once the DNS client received the host name, that host name will be sent as a form of a query to a DNS server. A DNS server is located in some other machine or in some other places, or it can even be in the same machine. But the purpose of the DNS server is to return or to give a response, and that response will be received by the DNS client, which basically the corresponding IP address for the host name, and the IP address will be sent to the file transfer client, and that will be used to go or to send data to the transport layer, because the lower layers, transport layer, specifically the IP layer, doesn't know about host names. What the IP layer knows only are the IP addresses. So what you can see here is that the host name and the IP address is just a mapping, and that information is provided by the DNS server. Now in the domain name system, we have what we call a domain namespace. The domain namespace is basically a tree, the tree data structure, wherein you have a root, and this tree has several children. Okay, and as you can see here, for example, you have ARPA, you have COM, EDU, org, add, ZW, etc. And these can have subtrees or children also, okay, or subtrees. Okay, and we'll see the function of this later. In this slide, it shows the relationship between domain names and labels. It's good to look at this by starting at the bottom. So you have at the bottom, let's say the host name or the domain name, in this case challenger.atc.fhda.edu, and if you move up, you become this one is a child of atc.fhda.edu, and then this one is also a child of fhda.edu, until it reaches the root of the domain namespace. Now to shorten the labels, to shorten the reference to these domain names, labels are introduced. So for example, the labels are just the host name, the specific host name. In this example, you have Challenger, because this is the name. You have ATC, you have FHDA, and you have finally EDU. When referring to domain names, we have what we call fully qualified domain names and partially qualified domain names. So when you use fully qualified domain names, you have this one, Challenger, ATC, FHDA, EDU, etc., etc. And for partially qualified domain name, this is the example. These are the examples. Now, in the domain name system, we have what we call domains. Okay? And basically, a domain is a subtree in the domain namespace. In this slide, for example, you have the .edu domain, or the edu domain, which is the entire colored yellow. And within this colored yellow, there is another subtree here rooted at this point. It is also treated as a domain. In this example, the .com or in the com domain is colored yellow. We can have subdomains within or subtrees within this domain. For example, this gray area, this subdomain is rooted at this node. And within this, you also have another domain that is rooted at this node. So that is very important to remember. Zones and domains. Zones and domains are related, but when you say zone, that is the place where, or the entity that is responsible for maintaining the information for the domain. In this example, you have this in the domain here is the pink area, and the yellow is the zone or the com zone. The com zone, you can think of it as a node that controls the or contains information about the domain. Within this domain example, you have a subdomain here, MHHE. And you have here both, okay, the domain, the zone and the domain together as one. Okay, so it means here that the zone and the domain can be separate. As you can see here, this example, the yellow is the zone and the pink is the domain. Now here in the MHHE case, you have the zone here and you also have the domain here. So this means that all the information contained here are managed by MHHE, because in some cases, even though this is the zone, it can still delegate the management of the information to some other servers. Okay. Now, there are two types of DNS. You have the primary server, which loads all the information from a disk file, and the secondary server, which loads all the information from the primary server, and this is called the zone transfer. So when you set up a DNS server, let's say for the zone, okay, you have a secondary server, then the transfer of data from this to this is called a zone transfer. Now, in the DNS in the internet, you have these different domains. You have country domains, the .ph, example, .sg, okay? Generic domains, you have .com, .org, .edu, and the inverse domain for reverse DNS lookup. And the process of getting the IP address given the domain name is called name resolution. So we are asked now, how do we resolve the name of how do we retrieve the name of the IP of a given host? There are two approaches in the name resolution process. We have the recursive resolution, and the first one is the recursive resolution, and this is how it works. You have the client, and the client is looking for a particular machine with a particular name. Let's say jach.fhda.edu. So in this scenario, the client will contact the server, the DNS server controlling that, and then it will forward the request to, if that information is not here, it will forward the request to the .edu server. Now, the .edu server, if it does not know the IP address of the machine or the host name, it will forward it eventually to the root server. And then the root server, I don't know that kind of machine, so it will forward this to .com, and then you have macro.com. For example, you are accessing a site in macro.com, so okay, this is what will happen. So it will move up to this server, and then it will return, go back. So this is called eventually the information or the IP address is given back to the original machine or the original server where the request was originally sent, and returning that to the client. That is the recursive. So what will happen in the main idea in the recursive resolution is the top level domain name server will do the request in behalf of the original machine, okay, the immediate machine where the request was sent. Now, in the iterative resolution process, example, you request macgro.com, the iterative solution, the top level domain name servers or the parent domain name servers do not perform the request themselves. Okay, so as you can see in this illustration, you have the client. The client will request to this DNS server. I don't know that, but you might want to ask .edu. So the client sends the request to .edu. I don't know about that, and then it will return to the client, and then maybe you can look at the root server, and the root server will go to the request, or the client will send the request to the root server, and the root server, I don't know about that, so it should return something. It should return something here, okay, and then I failed to copy the number 6. Maybe you can try .com, okay? You can try .com, and then it will return again. Okay, I missed 8, and then 9, and eventually giving the address for macro.com. Okay, so that's the iterative solution. Now let's talk about the format of the DNS packet. So the DNS packet is a very simple format because you only have a question, and you need to have a response or an answer. So in the left part, you see the query format, DNS packet format. You have the header and the question section, what information you're requesting. And in the response, you have the header, the question section, the answer section, and additional fields here. Right? I'll have an example later. The header format is a 32. The size here is 32 bits. So you have identification, flags, number of question records, and other information. The flags field, where is the flags field? This one here, right? This is the flags field. Okay, these are the different bit values for the flags field. Okay? The meaning of the R code, okay? You have no error, format error, problem, out name server, etc. Depending on the status of Okay, and the query format will be something like this: the query name, query type, and the query class. And this is the format. Let's say admin ATC FHDA edu. So 5 count 1 2 3 4 5 count 3 1 2 3 count 4 1 2 3 4 etc. Okay, regarding the types, the query type here, okay, we have these different resource record types. So you have the A record. That means, so you can think of the DNS as a database with the following fields. A is for an address, NS for name server, CNAME is for canonical name or an alias or synonym, SOA is start of authority, which marks the beginning of a zone. Later you will see an example zone file that illustrates how to set the start of authority. WKS, well-known services. PTR, pointer, it is used to convert an IP address to a domain name. It is a reverse lookup. We'll have an example later. So it's a PTR record type. Hinfo, host information. MX is a mail exchanger for email. 4A's for IPv6 address. AXFR, transfer of zone, request for zone transfer, and request for all records you have any. And for the classes, you have the usually in class for the internet class, because you can actually use DNS for other types of networks. So the resource record looks like this. You have the domain name type, the domain class, the time to live, resource data length, etc. So we have here a sample query which was captured using Wireshark. In this sample output, so you have the source. This is the client 10.0.2.4 requesting a resolution of www.example.com. So you have here the destination. This is the DNS server, so the protocol is DNS, and you can see here the format or the context of the information. So you have the flags, the question 1, answer RRs, authority RR0, RRs, and the query. You have here the query. So example.com, type A plus internet. So the field, the values of the field are name, type, and class. So it's summarized in this figure. Now, if the DNS server has the information, okay, for this query, it will respond with an answer. And this is the answers example. So from the source, which is the DNS server, it will send the data, the response to the destination or to the client, and it will respond with this information. So you have the request here, and the answer will be like this. So you have A in for the class, type A is an A record, address record, time to live, the length of the data, and the address that is in the database of the name server. So that means that www.example.com has an IP address of 10.0.2.101. And in addition to the actual record being requested, as shown in the previous slides, in the response, where was that? Here, so you have the answer question containing the IP address. There are also authoritative and additional sections. Okay, here, so this is the authoritative section. So this is the actual answer section, and this is the authoritative, and it returns that the name server is ns.example.com, which is the authoritative name server. Okay, so that is basically the mechanism of the DNS Now, where does the security come in? Okay, the main vulnerability that can be exploited in the DNS is the hijacking of returning the responses. For example, I have a domain, jackhermosilia.org, and jackhermosilla.org has a corresponding IP address in some DNS server database. Okay, and if an attacker can hijack my request such that in a short period of time I will receive an answer that is an spoofed IP address pointing to somewhere, then my site or my users will be redirected to a site that is not the correct site for jackhermosilla.org. Do you get the idea? So, for example, jackhermosilla.org 10.0.2.101 is the correct IP address. An attacker can hijack my or can return a different IP address. Let's say 10.5.2 point something, which is not the actual IP address of my site. Okay. So this is what you're going to do in the lab, and here are the things that you need to remember for the lab, and I'll show some screenshots later. So in the lab, you're going to use VirtualBox, and we're going to install Bind9, which is the implementation of DNS services. You get to install this in the setup. So for the lab, you have this setup. You need to have 3 virtual machines. Okay. First, you have the workspace 1, workspace 2, workspace 3 for the workspaces. You need to set up a NAT network, as we've done in the last exercise. Workspace 1 will be assigned an IP address of 10.0.2.4, which will serve as the DNS client, and workspace 2 will be given 10.0.2.5 as IP address, and this will be the DNS server, and workspace 3 will be the attacker. As I said earlier, the attacker will try to send a response, an answer to the DNS query of this client, so that it will override what is actually stored in the DNS server. Let's say I can use my own IP address that will redirect the request to that address. Okay? So here are some screenshots of the setup. I did the exercise yesterday and a while ago, so it is an easy exercise. So you have, I think in 137 you've already set up a DNS server. So you have here the zone file for example.com, which is required in the lab. So here are the entries. So you have the time to live, 3 days. You have the start of authority here, entry, and you have the name server, admin, and this serial number. Okay. Internet class, you have the name server and example.com, mail exchanger, and these are the actual A records. Okay, so actual A records. So for example, www.example.com will return this address. Mail.example.com will return this IP address. For the reverse zone file, for use in the reverse lookup, this is the entry. So basically, instead of A records, you have PTR records. To make sure that, or to verify that the DNS server is running or listening for requests, so this is workspace 2, you can use the netstat command, sudo netstat -tunlp pipe grep named. Named is the daemon for name resolution, and as you can see here, it is listening, or named is listening at port 53. DNS servers usually use this port number 53, both TCP and UDP, okay, depending on the size of the request and the responses. Uh, Here you have DNS client, you have workspace 1. To specify that the DNS client will request IP address or will request an IP address to a particular name server, you have to edit resolve.conf /etc resolve.conf. Take note that there is no E in resolve.conf, and you have to specify the name server, which is the IP address of the name server, as you've seen earlier. So this one here, okay, which is actually workspace 2. Okay, so once this is set, all name resolution requests will be sent to 10.0.2.5. So this example, we use the dig command, dig and the domain name. So this host name will be the request for this, the DNS request for this will be sent to 10.0.2.5, and it will return an answer. Okay, so as you can see here, this is the question section, the answer section, okay, and it returned 10.0.2.101, and the authority section, okay, the DNS and some additional section, okay, and for the reverse lookup, you can have you use -x option. Okay, so dig -x, but instead of using a domain name, you use an IP address. So dig -x 10.0.2.101 will return this. So it is in the PTR record, okay? And the actual domain name is www.example.com, name server and additional record. Okay, so for the next workspace, so you need to use netwag to be able to override the answer to the query of the DNS client. So you're going to use in the write-up for the exercise in the seeds lab, you're going to use tool 105 of netwag. So these are just example settings. You can use your own settings depending on your choice. Okay? Because, for example, you might want to use Facebook as an example, right? Because you want to try to attack your neighbors who are connecting to your Wi-Fi or access points. Okay, so these are the parameters. So the host name, and to see it in action, okay, here is the client. So we are here in workspace 1, and what I'm doing here is I'm repeatedly performing a dig on www.example.com, and as you can see in this illustration, for a few tries, it gave me the correct IP address, which is 10.0.2.101. So notice the timestamp there. Okay, they're just the same. So within a 1-minute interval, and then at some point you will observe that instead of getting 10.0.2.101, I got 1.2.3.4, which is actually what I set in the network. So that means that the answer from the attacker was received by the client first before the arrival of supposedly the correct query. And then when I tried again, it got the correct IP address. Then when I tried again, it got the spoofed IP address. So this is what you're going to do in the lab, and I'll just be adding the pairing in the later in this slide. So I forgot to run group view, so I'll just add it. I'll just print screen the output of group view so that you will know your grouping for this exercise. If you have other questions, you can just comment on the activities or on the assignment that will be generated for this exercise or this lab activity. So thank you for listening. I hope you will be able to finish this exercise. This is just an easy exercise. Thank you and enjoy.